So my name is Colm Divilly. I lead the development of Oracle REST Data Services. Oracle REST Data Services is a product that lets you connect your database 11 or later to the web. So what I'm going to be talking about today is how we use ORDS. We call Oracle REST Data Services ORDS for short. How we use that in the Oracle Cloud to power our Schema as a service and our Exadata Express services. Okay. I don't think I'm going to necessarily cover a lot. I'm actually going to mention one thing that we're working on to improve about the product in that regard in the future. But apart from that, this talk is mostly about what we have today. Okay. So the reason I'm here is because my boss, Chris, couldn't be here. He was supposed to be here. He was supposed to talk, and he asked me to step in for him. So I was asking him, well, what did you intend to talk about? And this really is the main point that he wanted to get across. So if your SQL is slow, you're going to be able to handle less users. A consequence of that is that in a cloud service, we're going to be able to manage less connections per second. So it's all about how do we make sure that we share the shared resources between the users fairly, okay, so that everybody gets a similar level of service. Okay, so I guess this is something that comes up for us with a lot of our on-premise customers. Our default configuration for ORDS is intended for a dev test environment. Okay, it's not sized for production. So I think we have like 10 is the maximum size of the connection pool. So if you have a business that's only going to do 10 transactions a second, that might be adequate. 10 simultaneous transactions. In production, you've got to remember that you've got to size your connection pool, figure out how many customers, how many transactions you're going to be dealing with it per second, and you're going to have to size your connection pool appropriately. The way that ORDS works, it depends on which feature you're using. So if you're using Apex, and you're using the PL SQL gateway, that connects through a user called Apex Public User. And so we have a pool for that. And if you're using Apex-based REST services, we have 2 additional pools to support that. They're connected as the Apex Listener pool and the Apex REST Public User. And then finally, and this is the direction that we're moving, is that for ORDS-based REST services, which is our newer way of doing REST services, we have an ORDS public user. To give you the history of that, obviously Apex public user has been around for years and years, so we continue to support that. Apex REST public user and Apex Listener were introduced when we started to add REST services to Apex. Strong feedback that we got from a good segment of customers was that they really liked the feature, but they didn't use Apex. So that motivated us to take that approach and rework it into a separate, independent facility, and that's what we call ORDS-based REST services. What we intend to do is to try and consolidate those pools back down to the ORDS public user over time, and try and eliminate, rather than having 4 sets of different connection pools to manage, to try and get it back down to 1 or maybe 2. Okay. In the cloud, actually, we have a facility whereby we don't use Apex Public User. What we do is we actually connect as each schema user, and we use the Apex REST Public User pool to do that connection. And we do that by doing what's called a proxy connection Does everybody know what a proxy connection is? All right, Dietmar knows. All right. So a proxy connection is where you connect as one low privileged user, and you previously have given permission for that user to switch to be, Scott or whatever your target schema is, and they can do that during the life of the original connection, and they can terminate it at any point and go back to being just the low privileged connection. The reason that we do that is that you don't necessarily have to have credentials in that scenario, and in the ORDS model, that's the only way you can get in, and it lets us multiplex a lot of sessions through one connection pool. Okay?
Is there an overhead involved versus directly connecting?
Yes, there is. Yeah, it's been improved a lot, and in 12c it's actually reasonably quick. It's a lot quicker than it was in 11. But yes, there is obviously an overhead for setting up a new session, but you don't really have a choice in a shared tenant scenario. You need to be connected as the schema owner, and I'll go into why a little bit further in the presentation. One of the things Chris wanted me to mention is that one piece of advice that he's gotten is that you should try and size your connection pools to operate at their maximum size continuously, okay? It's based on feedback from Andrew Halsworth, who's in the performance tuning team, I believe. And the reason is that when you get busy, you can get into a vicious cycle. You get busy, you open more sessions, the database gets busy opening more sessions, response times go down, requests queue up, you increase the connection pool to deal with those additional requests, the database gets even more bogged down, creating new sessions. You see how it happens, and you can get to a situation where he in that YouTube video linked to there, he shows how basically it just becomes this car crash as too many requests come to, and it spends too much time trying to increase the connection pool size. Okay. The next thing that you need to think about is, so in our schema service, I don't know how many schemas we have, but it's in the thousands, right? Okay. So, we have thousands of schemas, but we have hundreds of connection pools across different data centers and all that kind of stuff. And so managing them is really difficult for our operations team. And so we have some kind of, I guess, learnings or feedback from that experience of trying to manage that in our cloud. And my advice would be that you need to version control your configuration files in the same way as you would version control your application code. Okay? You need to know, when did that connection pool get changed? All right? And if you're just trying to work it out off of file timestamps in a production system, that's not really going to give you the visibility that you need. Okay? Equally, if you realize, okay, we did something wrong, and we need to go back to where we were before. Do you want to be in there and editing VI and trying to copy the old configuration back in? You want to have a way to roll back to the previous state. Okay. One thing that we see customers do, and we've even seen it internally, is that people create configuration files for databases that aren't up or don't exist. And so ORDS spends a lot of time trying to interact with those configuration files, and they're not going to point to anything, and it's going to cause problems. Because people edit the configuration files, because they change them or whatever, when ORDS starts up and when it first encounters a new configuration file, it validates that configuration file to make sure it's actually valid, all right? And if it's not valid, it blacklists it for the default timeout period is 15 minutes. You can adjust that. So you can have a situation where you could have a configuration file that's pointing to a database that isn't up, and if you have like 10, 20 of those, or just there trying to make a connection to them, all the time requests are coming in from your actual business, and so you can get a very slow response time because Ords is busy trying to validate these connections that are never going to validate. So my view would be that you would never have in your production configuration folder configuration data that's wrong, basically. So I think it's important to make that point. I think the bottom line is, though, that having hundreds or thousands of configuration files, if you're operating at Oracle scale, is not a good solution. So this is the features bit I was talking about. I reserve the right to completely never deliver this feature or do it totally different or whatever, but our intention, what we're working on, is that we will have a centralized service that when a request comes in, we will map a host name to a given database pool in a database pod in a particular data center and a particular PDB and schema and user. And that service will give you back the configuration for that particular pool. And the first time it gets it, it'll create the pool, and the subsequent times it will have cached the pool, and the pool will just be existing. So I won't try to recreate it. And basically, the problem of operations managing all of these on-disk files becomes our problem of we have a database, which is the ideal thing to track all of these mappings from customers to particular database schemas. Okay. One of the things that will really do is that we will have no local state on each node, each app server node, okay? So that will allow us to move to a more stateless model for our WebLogic nodes. We'll be able to containerize them. We'll be able to use Docker or Kubernetes or technologies like that. The only thing we will need to do is point this server at the central service, and then it will be able to interact with that and get the configuration data that means. That also means that if we need to spin up a new WebLogic, it's not a matter of somebody provisioning a folder, getting all the configuration files on it, testing it, all of that kind of stuff. They provision a new WebLogic instance, they point it at the server, and it's ready to go. So that should help with our kind of elasticity, if you like. Sorry, John. Okay, so the question was, that feature, is that something you're planning to deliver for on-premise? And the answer would be, at the moment, no. Okay, but if you have strong feedback on that. Yeah. There is, of course, a cost to centralizing all of that data. Now you have this one critical server that you have to make redundant, and that has to be managed. And so you're centralizing that complexity rather than replicating it. But the complexity doesn't really totally go away. So I would say that for most on-premise solutions, if you're not operating at scale, you don't need that additional complexity. A file system will be fine, good enough, basically.
Can I ask a question?
Sure.
On your earlier point, when you talk about the unused, not yet provisioned configuration files, would you say the same behavior of Ords applies if, like, the database password is invalid or the account's locked? Will it still spend cycles trying to connect to something which will never work?
Yeah. So the question was, so what if the configuration state effectively becomes stale because, say, of a password rotation policy that the password would expire? Yeah, in that instance, the connection pool would exist. It depends on the state. So if the connection pool already exists, then it's on the connection pool side. It will try and, if a connection has been reused a maximum number of times, then it will try and acquire a new database session using the credentials that are in the configuration file. They'll be out of date. It'll get an error. It won't be able to retrieve it. And so eventually, over time, as those sessions that are in the pool age out, you'll end up with a useless connection pool, and you will be getting server unavailable errors. Okay? And they will be reported as server unavailable errors rather than a 500 internal error. If, on the other hand, the connection pool didn't exist, so or just starting up, and the data was already stale, then ORDS will, as it's trying to create the connection pool for the first time, what it does is it goes and it creates a single connection, not even a pooled connection, to that server with those details. If it fails, it blacklists that configuration for, like I said, 15 minutes by default, so that it doesn't get bogged down. You know, we know this thing's not good. We'll ignore it for 15 minutes. We'll give it another chance in 15 minutes. Maybe they'll have updated the configuration files, whatever. Maybe the server will come online. We'll try again then. And you can configure that timeout to suit your environment. Okay. So what I wanted to talk about now is that I guess the model in the cloud of how you interact with the database, the kind of granularity of the call, the duration of the call that you have would be different to if you had a co-located application server and a database server, okay? So I can imagine that in many use cases, people will see nothing wrong with holding a connection open for 2 minutes, 3 minutes, 5 minutes, whatever, in an application. Say it's doing some kind of batch processing or whatever. Unfortunately, that model is not going to work in a shared tenancy situation in the cloud, because you're going to hold that connection for and diminish the resources that are available for other customers. And so you're not going to be given that time, to be honest. So that does have an impact, right? That materializes as you may have to change how your application works to make it work in that environment, okay? So basically, you need to do everything as efficiently as possible, okay? But you don't want to have lots of short calls either, okay? So you want to get the right amount of data for your application. So typically, I would say that you want to get a page worth of data, okay? Okay. The next topic is how do we configure the database to ensure that no one tenant monopolizes the resources of that database, okay? I don't know if any were here for the last session. The presenter signed up for an Oracle Cloud account, and before the end of the first day, he had used all his quota, right? So there's a feature in the Oracle database. There's nothing to do with ORDS itself, which allows you to set policies in how to share resources between tenants. Okay, and Joel, who's here with us in the room, wrote a great blog post back in 2009 about it, and I was actually going to go through that blog post, all right, because it says it better than I would say it myself. All right, so basically what we do, it's probably a little small, and let me remember the zoom plus. Okay, everybody read that okay? So you use a package in the database called DBMS Resource Manager, and basically what Joel does in his blog post is create 3 different groups, consumer groups, okay? And there's a bunch of code to basically configure that. But the main point is that you start off in high priority. You go on too long in high priority, you get bumped down to medium priority. You go on too long in that, you go down to low priority. And this is used on apex.oracle.com, and it's used in our schema service and also in Exadata Express. This piece here about connecting as the Apex public user, that's true for apex.oracle.com. It's not true for our cloud offerings. Like I said, we proxy to that particular schema, and that enables us to target the resources, the resource sharing to that particular schema, and give you each tenant their own particular quota. Okay? So if that's not something that you've used in your applications, I would highly recommend it. We've, of course, had lots of teething problems with folks trying to monopolize apex.oracle.com, accidentally. So it's a proven and robust solution that runs on pretty humble hardware, right? apex.oracle.com, and we're able to manage how many?
38,000 tenants, and we get 1,700 new every week.
38,000 tenants and 1,700 new a week.
Yep.
Yeah. So that's pretty impressive. So I think, and a key part of that is this facility, right?
And it's in one Oracle database. It's in one Oracle database.
Yeah, it's one physical Oracle database. Okay, so I'll return to my presentation. Okay, and that's okay. So we just talked about how we manage the sharing of resources. But the other side of that is we want to isolate tenants as well from each other, okay? We don't want you to be able to see some other tenant's data, okay? We call that locking down the database, okay? In the schema service, we have written our own custom lockdown process that uses triggers to prevent certain SQL operations. And we basically combed through the Oracle database source code and figured out all of the privileges that are granted to public and revoked all of those that weren't needed. All right, so that took a long time to do. In 12c, which is what we use in the Exadata service, Express service, there's a lockdown facility in the database, okay? And so we use that. We actually have, I meant to link to a white paper that describes the lockdown in schema service. We have to disable some facilities, okay, because they're just not, you can't have B files, okay, in that environment because we can't give you access to the physical disk and so on. Yep, so as I mentioned, the features, okay. I was there a day ago. I don't know. They must have changed it. Okay, I'll have to double check that link. I'll fix that before I re-upload my presentation, so you can check it afterwards. And the U.S. Department of Defense has some very good papers on how to lock down your 11 and 12c database environments. Okay, so I'd recommend going through those as well. Okay. Okay, so the next thing that I want to do is demonstrate how you can migrate your REST services from dev to test to production. Okay, so I'm going to try a live demo. So wish me luck. Okay. So bear with me for a second. I'm just going to start up my database. So I labeled this snapshot before messing because I got a notion during the week to try and do my symposium yesterday using software only from 1997. So yeah, it was a lot of messing. It worked though, eventually, sort of. Okay, so my database is up and running. Okay, and I'm just going to launch SQL Developer. Okay, and I'm going to go into my SQL developer folder and do ./SQL developer sh. Okay. It's going to launch. Ah. No, it's not, because I forgot to do jhome. So one interesting thing about ORDS and the Java version that it uses, sorry, that's 1.8, is that we still have to support JDK 7, even though JDK 7 is end of life, because the application, one of the applications service that we use, WebLogic 10.3.6, is still in support until 2018. So we have to continue to support that environment, and so it only works with JDK 7, so therefore we must work with JDK 7 until sometime 2018. We would dearly love to move away from JDK 7 to JDK 8 to JDK 9 when it comes out later this year, but for now we're stuck with 7, and that's why SQL Developer, which only works with JDK 8 or later, was complaining there because my environment was set up for JDK 7. So now we're starting. This is another area where I'm talking about features. You check the version on that, right? Okay, so let me just blow that away. Okay, so I have my connections down here. I'm going to go to a schema called tickets. This is an example that I've built for demonstrating REST services that I use in some of my talks. It's basically a ticketing system, like an issue tracking type system, and it has a bunch of tables in it. But what's interesting is it also has a bunch of REST data services. Okay, so this is a new feature that's coming on SQL Developer, is the ability to model REST data services on your connection as just another object, just like your types, your triggers, your tables, your views. Okay, so I can expand my list of modules. Okay, and I can see all of the modules that I've created. In Oracle REST Data Services, we model REST services as what we call resource modules. They're a unit of organization. They're equivalent to a PL SQL package. It's just a way to group related services together, okay? So we have modules, we have privileges, which control access to the resources, and we have what we call logical roles, which restrict which set of users can access a particular resource, okay? So you can...
Those facts that be displayed from that widget in the ordinary catalog, the ordinary data dictionary.
So the question was, are these icons here being surfaced from data in the Oracle Database Data Dictionary?
Yes.
Yes. And so the answer is no, they are coming from the Oracle REST Data Services metadata directory that we have. So
File system?
no, not off a file system. So the configuration files only configure what database to connect to, but the actual definition of the REST Data Services is stored in a schema, and I can just quickly show you rather than try and explain. So if we connect to my sys, other users, I'm not going to try and correct directly to the schema because we lock this metadata schema from access, because there's no reason to connect to it directly, and so for security we disable access. So we have this schema called ords metadata. Okay.
So very loosely, it's like CTX sys or something like that. It's ords sys, its own schema in the database for your metadata.
It's analogous to the way the XDB has its own repository. This is our own repository where we define the metadata about the resources. So we have a bunch of tables in here. There's the OAuth related functional. This is the modules. Okay, so this is the list of data that you're seeing down below, okay? So this data is exposed as a bunch of views. Okay.
Is that in the sysops tablespace, like most of the other schemas?
It's a good question. I don't know the answer off the top of my head. I don't recall. I think we are, right?
It is actually configurable, so you can, when you install boards, you can say what tablespace.
Oh, yeah, yeah. Same as when you install Apex, you can choose what tablespace. Yeah. But
the usual routine of DBA in all the users?
we have users underscore, and we have, we don't have DBA. We should have had DBA. And there is no concept of all, because in ORDS, in usage model, you cannot give, Scott cannot give HR access to its resource, to its REST services. It doesn't make any kind of sense to do that. Okay, you know, if you have REST services, they're surfaced through your own URL mapping. So there's the users underscore view. And I was just about to show that. I can show that here. You don't get a view created on your individual schema. Okay, you have there's a public synonym, and it points to the users underscore views, and that is what this UI here. When we go look at our REST data services, where are we gone? Okay. So all of this data here that's popping up is coming from those user underscore views, okay? So you might use our PL SQL API, or you might use the GUI in ORDS, in SQL Developer to create a module, okay? And so we can create it like that, okay? Okay, we can finish that. Okay, so in the background, it fired a PL SQL command there. It called into the ORDS API, okay? And now I've created that module, but what I wanted to show is that I can, sorry, not all the modules. I can go to REST definition, and I can go to save to file, okay? And it gives me a couple of options. So when you define REST services in a schema, you need to enable them. You need to enable that schema. By default, we do not let any schema be accessed via ORDS, okay? That would be a bad thing, okay? So you have to opt in to saying this specific schema where I'm going to put my REST service definitions, I'm going to enable that and make it visible to the web, okay? It also asks me if I want to pull in the export all of the privileges and roles that relate to this module, okay? And it asks me for the name of a file. So let's give it another name, okay? And I can press apply, and it's going to, this code is querying those data dictionary, quasi-data dictionary views that we've defined, and introspecting that and generating the original scripts that were used to create the definitions in the first place. So we had an existing kind of XML-based import-based facility. We're continuing to support that. But I think for a lot of people, particularly in the database world, this feels like a more natural way to deal with their resource module definitions, okay? And you can create them interactively, and then out of that, you can generate a script that will faithfully reproduce those modules, and you can take them to any environment, to any database deployment. Question?
Yeah, can you define it for anything good at the result of the template level? Like export just the one template within that module?
No. So the question is, what's the unit of export? What's the smallest unit of export? And the smallest unit of export is a module. Okay.
I guess you could script it out again.
Yes, you could. So just about the API a bit. I mean, if So we call each of our methods, we call them define, okay? In our first attempt in calling them, we call them create, okay? And this created a problem when you run the create a second time because it already existed. So we changed it to define, and what we mean by define is the same as what you say when you're creating a view, create or replace, okay? So define to us means create or replace. So if it's not there, it will create it. If it is there, it will override it. So to John's question, if you wanted to just, you updated one particular template, you could pull out just that particular statement. And assuming the module in which it already exists in your target environment, then this operation should succeed without problem. Okay. So that was all about defining modules. Any further questions on that before we move on? Okay. So like I said, this is a new feature that I believe is not yet shipped in SQL Developer. Is that right, Jeff?
The only thing that's new is the save to file clipboard. You can still generate the script.
Yep. All right. Okay. So that's already shipping, and okay. So that's great. Okay. Return to the presentation. Okay. Play on from there. Okay. So the next thing I wanted to do is try and give you a bit more insight into how we manage our connection pools and how we multiplex many, many sessions across those connection pools. Okay. So when we were starting with this problem, we didn't really have a clear idea of how we were going to try and solve it. Back when 12c was being developed, coming from the 11g world, we were thinking, wow, we're going to need to have a connection pool per PDB, right? And then we looked at what kind of density we'd be able to achieve by having a connection pool per PDB, and it wasn't good, okay? Because a connection pool has quite a big overhead in terms of it needs, in terms of the overhead on the JVM, okay? So we were trying to figure out, well, how can we reduce the number of connection pools? And we need to kind of make our connection pools, number of connection pools constant, rather than growing per customer or growing based on some metric that's going to change over time.
Do you mean the connections in the pool or the number of separate pools?
I mean the number. So the question was, do I mean the number of connections in the pool or the number of actual separate connection pools? And I mean, I'm talking about the number of separate connection pools. Okay. So a naive model would be to have a separate connection pool per PDB. Okay. And as I said, that wouldn't scale as you add customers because each one gets a new PDB, each one gets a new connection pool, and your JVM runs out of memory pretty quick, or you end up spending lots of money provisioning new JVMs to handle all those pools, which in reality will have a lot of idle time. We hope, right? Okay, we expect. We need to achieve better density than that. We need to have really one connection pool per database, per container database. And we eventually figured out a way to do this, and that's what I wanted to talk about now. Okay. The other side of that is that we need for it to be stateless. Okay, we need that, as I talked about earlier, your session not to leak data to somebody else's session. Because remember, these actual database sessions, they're sitting in a pool, they're being reused typically 1,000 times before they're thrown away, and a new database session is created. Okay, in those 1,000 uses, it could service 100, 200 different customers during that lifetime, and we don't want any state from any of those tenants leaking to another. All right, so just to explain how we actually do it, we connect as Ord's public user, and I'll just take the example of the Oracle REST data services-based REST services. The same principle applies to all our pools. We connect as that user to the CDB, okay? So the connection pools are sitting there inside a JVM, inside a WebLogic, waiting for requests to come in. When they come in, they can connect to that CDB as ORD's public user, and ORD's public user is created as a common database user, okay? That user exists in the container, and it exists in every single pluggable database as well, in every single PDB. We have a central mapping of, for a given tenant, what's the pool that they're in, which means what's the CDB that they're in, and what particular PDB they're using, and what the identity is of the default schema that they're using in that PDB. So when a tenant signs up for an Exadata Express service, they get their own PDB, and we create a starter schema in that for them to use immediately, and then they're free to create additional schemas as they see fit. Okay? We have that information about what PDB we need to go to. So we, at the start of the interaction, do an alter session set container equals the name of the container. Okay? That now switches the ORD's public user session to be connected to that specific PDB. Okay? And just so you're aware, because something that I guess caught us out when we were figuring this is the way the database implements that is that actually you end up with two database sessions. Okay? You have the CDB session, which is still there in a kind of a dormant state, and then you have a new session specifically for the PDB. Okay? So you actually.
You mean that second? You're talking about the foreground process.
Yep.
And that's spawned in the moment.
Yes. Yep. So it's spawned when you do the alter session set container, and it's terminated when you do another alter session set container to some other PDB or to the CDB route. Okay.
So where is the economy of the connection pool? Because in the earliest days, when you just did a CGI bin thing and it ran up SQL Plus,
yeah.
People in later years lampooned that because of the cost. The cost was supposedly starting up the foreground.
Because we're sharing these connections in a pool, so you're not getting one, for the life of your, say, long-lived interaction with the database.
But which element is long-lived? It's this
Nothing.
Session attached to the CDB.
Yes.
The root session.
Yes. Yeah.
So that is it a lucky outcome that the cost of spinning up a new foreground for this request only, and then letting it die after that request is done? Is that trivial?
It's not trivial, which would go back to Dietmar's question about, is there a performance hit for it? So is there an overhead for it? Yes, there is. But it's like, do we take the performance overhead of doing this additional alter session and creating another session, or do we try and manage and scale out the many connection pools per PDB, and that wouldn't scale. So it's like either we can make each transaction take a little bit longer and manage the size of our pool overall, or the number of pools. So it's a trade-off. Okay.
Just to be specific, this session cache cursors idea that you've given up on that.
So I'll come back to that in a minute, because that touches more to the concept of creating a proxy session. And we can probably talk afterwards. I have a very strong, almost quasi-religious view on caching and all the session management that the database does. And for my use cases and applications, it does not add value for me. And I would very much like to see it go away, but we're getting off topic. The next step is that it creates a proxy connection to the particular schema that we're going to execute the REST services in. And Actually, I misspoke there. That's where the second session comes about, okay? So this is not quite accurate the way I'm saying it. I confused myself. So it's at this creating the proxy session connection that the second session is created, okay? And I've got a typo there. Okay. So now we're connected to the particular PDB, to a particular schema as a proxy connection. Now we go execute whatever SQL or PL SQL is defined to be executed for the REST service. Okay? We do all of that. We do a commit at the end if it's a post or a put or a delete. We don't bother if it's a get. It's not accurate. If it's a query, obviously there's no commit. But if it's a PL SQL block, we do a commit. You shouldn't change state during a get request, but we don't know that you might have some reason to do that. Maybe you want to do a one-time key generation or something like that. Okay, so when the request is completed, then we need to clean up all of that state. Okay, we close the proxy connection. That tears away the proxy session. So any cursors that may have been generated during that interaction get blown away. Any cache data state that's there, that's all gone because you can't share it because you don't know that the next request that you're going to service is for that same tenant. Okay, it could be for a completely different tenant. Okay, and then so that destroys all of the session state. Okay, so that's how we guarantee that isolation. So from my point of view, in terms of delivering a correctly behaving application, that is a key feature in my view. It guarantees to me that no state will leak across our requests. But obviously there's a performance overhead in that it takes time to perform that proxy, to close the connection. And actually closing a proxy connection is slower than opening a proxy connection. At least in my testing on my development environment. I'm sure somebody would tell me that that's not a good test. Sorry, you had a question?
So you mentioned proxy connections. Which database company is the proxy connection?
Yeah.
Which database company are you using for the proxy connection?
So it will be a database schema in Exadata Express by default. It will either be a schema that you created yourself. You might create a schema called HR, so it would be that schema. Or as part of provisioning you for a service, we generate a 8-character randomly named schema name. So it'll be some random name like that. If you ever use Apex and Exadata Express, you'll see up in the top, some random string. That's the schema that we're connecting. No, so this proxy facility is all in the database that's happening. Yeah. Okay. The last thing that we do is we alter the database session to point back to the CDB root. We can't leave it pointing at the PDB. We originally wanted to do that. We were thinking that that would be a nice optimization. If you access a PDB in one request, it's quite probable that there will be a subsequent request going to that same PDB. We should be able to hold that session in the pool and get it back and let you carry on. Unfortunately, that doesn't work when you deprovision the PDB or if you rename the PDB.
How do you arrange that your request uses a particular edition?
Of the database? Yeah. Okay, so Bryn is asking me about edition-based redefinition. I know that Bryn is product manager for that, and that's all I know about that product. So I can't answer your question. Probably we need to talk, and you should figure out the answer to that question. All right? So the reason that we can't leave it pointing at the particular PDB is because it can be renamed, it can be deleted. And if you try to connect, if you have a session to a deleted or renamed PDB, that's a bit of an edge case that the database doesn't deal with gracefully. It may have been fixed in the interim, but in our testing, it it caused a trace file to be created in the database, and the session itself went bad. So what we do is we point back to the root. Sorry, there was a question?
I guess I was trying to understand that. Sorry, will it effectively poison the session pool itself?
The connection pool, yeah, you'll get a no more data to read error, read from socket error on that connection, and all of the any of the active connections that are in the pool that happen to be pointing to that PDB. Yep.
But in another way, are you using this famous PBMS SQL to dot around, or are you doing successive top-level calls of the session, go down here, then log on as a proxy?
We're doing alter session as a top-level statement. We're using a facility in JDBC to open a proxy connection, and then we're issuing whatever statement is defined in the resource module definition. Okay. Okay. So I'm a computer programmer. I am not an artist. All right. Okay. And I hate using those the widget drawing things that are in Keynote. I mean, life is too short for me to use those, basically. So I have a technique where I draw it out in paper, I photocopy it, I scan it in, and that's the kind of lovely art that you get, okay? So this scroll here is saying HTTPS, okay? That's probably the most unclear piece of text on that. All right, so this is the architecture of the Oracle Cloud Schema as a Service and Exadata as a Service systems, okay? So out front, we have this system we call Big IP. It comes from a company called F3 Networks, I believe. It's basically a load balancer and a HTTPS terminator, okay? So it's got hardware dedicated to accelerating the creation of HTTPS sessions, which involves a fair bit of cryptography and traditionally has been a bit of a performance bottleneck in web environments, okay? So then the request is forwarded over a HTTP internally to Oracle HTTP server, okay? And this has integrated into it Oracle Access Manager, and this is determining, is there a cookie associated with this request, or is there an OAuth access token associated with this request, and validating that, and either showing you the sign-in prompt or giving you a 401 unauthorized status. Okay? So that's off to the side, we have the Oracle Access Manager and IDM infrastructure. And to me, they are just a black box. I'm sure there's quite a bit of complexity in their own configuration. But to us, they're just a black box. Then we have a WebLogic node, and we have a second WebLogic node for redundancy. So the OHS level is monitoring this node, and if it detects that it's not responding in an adequate amount of time, it flips over to using the other node, okay? In a lot of Java web applications, folks use the sessioning capabilities that are in WebLogic in their app server, and that will mean that effectively a user session for a given sign-in will be pinned to a particular node. We don't use sessions at all, and that's quite a deliberate choice because we don't want to be pinned to a particular WebLogic node. If this one goes away and this guy comes up, he can carry on doing the exact same work, okay? There's no need to replicate session state or any of that kind of stuff, which is quite a challenging problem to do at scale, okay? And if we get busier, we can just add more WS nodes at this tier here, and then we can change the configuration to round robin or whatever algorithm we choose to distribute the load between those nodes, okay? So that goes back to earlier what I was talking about, the node should be stateless, okay? Just blow it away if it's not working, start up a new one, okay? then that has all of the configuration state in it on the local disk at the moment, and we will move to a central server in the future. And that tells us how to connect to whichever DBs. And there's one central DB that has the mappings of, for what tenant, what database pool to go to, and all of that kind of stuff. Okay. So that completes my talk. I'm happy to take questions. Happy to chat afterwards. If you want to learn more about the product, oracle.com/rest will take you to our OTN page, and you can download the product. It's a free download and covered under your existing Oracle database license. And if you could give us a follow on Twitter, Oracle REST is the product page, and Divilly is my handle. All right, thank you.